I start with LHS. So in LHS, there is mod of f of z. So what is exactly mod of f of z? That is nothing but under root of u square plus v square. So we need to differentiate that. So I say I take one by one. First I'll finding this, next I'll finding this, and then we'll add. So dou by dou x of mod of f of z, that comes as dou by dou x of under root u square plus v square. So we know differentiation of under root of function, that means differentiation of root x is 1 upon 2 root x. So I can write as 1 divided by 2 root x, that is u square plus v square. But since u and v, we are differentiating with respect to x, and u and v are the function of x, so further I need to differentiate this, which will be coming as 2u, and differentiate of u is ux plus 2v, and differentiating v is derivative of v is vx. So which comes to be, I can say 2 gets cancelled, and I get 1 divided by under root u square plus v square ux plus vx. Now next term is similarly dou by dou y mod of f of z, that come as again the same thing. So I can directly write here 1 divided by under root u square plus v square. There will only change with variable. I can write uy plus vy. So let's say this has got as 1, this has got as 2. Now we need to square it also. So when you square it, you get dou by dou x mod of f of z the whole square as 1 upon u square plus v square, and squaring of this, that is ux plus vx the whole square, which comes to be, we know that's easy, a plus b the whole square. So u square ux square plus v square vx square plus 2uv ux vx. So this I got as first term. Now second I'll be getting as dou by dou y mod of f of z the whole square, so which I get as squaring of this. So similarly I can write directly 1 upon u square plus v square u square uy square plus v square vy square plus 2uv ui and vy. Now we need to add this both. So I can write therefore dou by dou x mod of f of z the whole square plus dou by dou y mod of f of z the whole square, that will be equal to, I can take 1 upon u square plus v square as common, and further you can write, understand students, when you add this equation with this equation, you can take u square common, you can write ux square plus ui square, and then here v square common, you can write vx square plus vy square, and the next term is plus 2uv common, you can write ux ui, that is nothing but ux vx plus ui and vy. So further I can just solve this, 1 divided by u square plus v square. Here I get as, by using analytic function, you can write u square ux square. We know that we want all things in x, so where we can write ux is equal to vy and ui is equal to minus vx. So here I write ui is equal to minus vx, but minus vx square will be nothing but vx square, v square. Here vx square is already there, vy can be written as ux, so I write ux square, and here both terms, that is plus 2uv, first is ux vx, let it be in the same, and second will be in minus of ux vx, because with respect to analytic function you substitute, and this gets cancelled. So I get finally 1 divided by u square plus v square. Here I can take ux square plus vx square as common. So another I'll be getting as u square plus v square, which can get cancelled with this term, and finally I get ux square plus vx square, which is nothing but mod of f of z the whole square, and I can say that as RHS. Thank you for watching video.